Welcome to homework.
So if we want to use the midpoint formula for this, um, all we really need to do is first find what is our delta x. So remember, delta x is supposed to be b minus a over n. Um, so our b in this case is 8, our a is 0, and the number of rectangles we want is 4, so that's going to be 2. And then we need to find our set of partitions. So we could either just use like this formula here to get them, because remember, each xi is going to be xi minus 1 plus delta x. So we could go about doing it that way, or we can just create our first set. I normally like to create this thing called like the set of partitioning points, and then I would just find the midpoints of all of those, and then I can just plug them in directly. So that's the way I'm going to kind of do this. So first, if we were to partition this normally, so we start from 0, a, and then we're just going to keep adding delta x like we had here until we hit b. So it would be 0, 2, 4, 6, and 8. And then we have this new partitioning set, which is going to be for the midpoint. So then we just average these. So the average of 0 and 2 is 1. The average of 2 and 4 is 3. 4 and 6, 5. 6 and 8, 7. And so these are going to be the numbers that we would end up plugging into here. So let's go ahead and actually set this up. So our delta x in this case is just going to be 2. So let's kind of write this out. So it would be 2 times, and then our f is what we have on the inside here. So it's going to be sine of root 1 plus sine of root 3 plus sine of root 5 plus sine of root 7. Then we can just go ahead and plug these into a calculator. And actually, I already went ahead and found these earlier. So this would be 2 and then 0.84147 plus 0.98703 and then plus 0.78675 and then honestly for 7, 0.47577. And then we just need to multiply all these together, or add them all together and then multiply. So that would give us, so approximately 6.1820. Actually, how many do we need to round to? 4 decimals. So yeah, that would be good enough. So this is what we would approximate. So this is approximately equal to the integral from 0 to 8 of sine of the square root of x dx.